Is it clear now?
Yes, ma'am.
Okay. So in the previous class, we have discussed about the how the transactions were happening and how a transaction is created and what is required for the creation of transaction, the about the inputs, the outputs, and how a transaction is propagated into the Bitcoin network, right? So all these things we have discussed in the previous class. So we'll continue with that. So this transaction that has been created by Alice on Bob's coffee shop. Now she has paid the money, but still it will not be added into the blockchain until it is verified. Okay, until it is verified and included in the block. So to verify and to include in the block, it goes through a process called mining. So already we have seen what this mining is, and in detail we will see in the next module. Okay, so as of now we'll see what the purpose of mining. So the purpose is since we don't have any central authority to monitor our transactions, the transactions has to be validated by something. Okay, so we need to have some methodology. So for that, this Bitcoin's protocol is having some rules, the consensus rules, where every participant in the network has to agree upon the or has to come to an agreement on the state of transactions. So this will provide the security for your Bitcoin transactions. So if any invalid transactions comes, then that will be rejected. Okay, and here the second point is it will create a new Bitcoin. It will create a new Bitcoin in each block. So whenever a particular transaction is verified by the miner, then the miner will be rewarded, and he will be given a new Bitcoin as a reward, so that a new Bitcoin is created. And it's just like printing money by the central bank, okay, in a traditional currency. And so this we have seen. And what this transaction, so this transaction requires an enormous amount of computation. So in the previous class, I think we have discussed on this Sudoku puzzle. So based on the complex, the difficulty of the puzzle will be, it keeps on increasing. The computation gets complicated and it becomes difficult. So as the blocks getting increased in the blockchain. And here this puzzle is something similar to a cryptographic hash. We'll see what it is. So before that, students who are joining late, please make a note, kindly join on time. So if you're joining late, every time I have to admit you and it disturbs the class. So please join on time. Okay, so now before going that, now we need to understand who is this miner or what is a miner. So we may think that a miner may be a person who is sitting in front of the system and doing the computation, like solving a Sudoku puzzle. But miner is not a single person. It is a group of specialized computers or some supercomputers which could do heavy computations. So this Bitcoin mining is basically done by this specialized computers. So each node will be having high power or super power computers which could solve the computational problem. And the role of this miners is to again secure the network. So that's what we have seen in the previous slide. So every transaction has to be validated. So this validation is done by this miners by solving that puzzle. So once this is validated, then the transaction will be included in the block, and that block will be added with the blockchain, okay, along with the other blocks. So in Bitcoin, the transactions are taken as the input. Okay. For example, transaction between Joe and Alice, between Alice and Bob. So these transactions are taken as the input, and it goes through a hashing algorithm. This hashing algorithm and all you'll be studying in your cryptography. So you just know that this algorithm will produce large numbers, usually written in hexadecimal. Okay. So for whatever the input size, it will produce a fixed length hash value. I'll give you a small demo now. And so this Bitcoin is using the SHA-256 hash algorithm to generate the random numbers, and which requires a huge amount of CPU effort. So mostly nowadays this mining is done by proof of work algorithm, which is called as Hashcash. And this Hashcash, so this will, when a miner wants to add a particular block to the chain, okay, blockchain. So what the block will be consisting of is a set of transactions, the recently produced transactions which are not yet verified, that will be added into the block. And once the block is verified and validated, it will be added to the blockchain. And so so as we discussed, this miner is not a single person, but it is a set of specialized computers. And it is not easy that a person can have such kind of setup for his own. And usually it will be done using a company or a group of people having their specialized computers for them. And the advantage of that is that, yeah, a group of people join together to use all the resources. And hence whenever a particular block is uh, validated by them, whenever a particular block is validated by them, the reward can be shared among them. Okay, that is that is an advantage. My students who are joining late, please make a note. Hereafter, I'm not going to allow you in the class after the start of the class, because if you keep coming till 9:45, then it's disturbing. So please join before 9 o'clock, before the class starts, whatever the time it may be. So now we take an example. For example, Jing is a person who runs a mining farm. Okay, that means he runs thousands of specialized mining computers to find out the solution for the block of transactions. So whenever a new block, students kindly wait for 1 second. Okay, so now Jing is a person who runs a company or mining firm which consists of many specialized computers, and a group of computers are used to find the solution for this block of transactions. So many people were involved in that, and this proof of work. Okay, this is the thing which is helpful to find the solution for this puzzle. Now, this requires quadrillions of hashing operations. Quadrillion, it is 10 to the power 15. Okay. So you can see the amount of computation that has to be done for computing one puzzle or one computational problem. Quadrillion is something like 1 followed by 15 zeros. Okay, 1,000 million millions. So this much of computational power is required to solve every problem. So now different miners in the network will be working on to solve this puzzle. So now we have seen that Alice has made a transaction to Bob, okay, and that is bundled into a block. So a block will not be having only one such transaction, it may be having hundreds of transactions. So all these transactions has to be valid. So all these transactions will be bundled in one block, and when this block is created by a particular miner, then it will be propagated throughout the network, and every miner present in the network, he will be trying to solve the puzzle. Okay, so the first miner who solves this thing will be he will publish that into the network that he has solved the puzzle, and he will publish that block into the blockchain. So immediately the other miner will be creating another block, and that he will be propagating into the network. So once the previous block is added to the blockchain, the miners will stop working on that previous block, and they will start to work on the next block, because it is known that they have lost the competition. Okay, already a particular miner has solved the puzzle, and he has published it into the blockchain. So now they will start working on the next block that is propagated into the network. So this now once this particular miner who if he has solved the puzzle, then it will he will be, if he is a part of this mining pool, then the amount he is getting as reward, it will be sent to that mining pool address, so that every participant who has shared their efforts will be rewarded accordingly. Okay, based on their effort they have put into that solution, they will be rewarded. Okay. And so as they are doing this, so that is what we have discussed here in this slide. So as they are doing that, this transactions, when it is added to the new block, it will be based on the transaction fee that it is that it has fixed. Okay. Yesterday we have talked about the transaction fee. I hope you remember. Do you remember that? Can I get some answer? Yes. Are you all here?
Yes, ma'am.
Yeah, transaction fee. We have seen an example of Alice transactions. She used only 0.015 bitcoins for purchasing the coffee. The remaining is 0.085. But out of that, she took only 0.0845 as her change, and remaining 0.0005 is given as a transaction fee. Similarly, every transaction they will be giving a transaction fee. So in a block, if there are some 100 transactions available, then if that block is solved by a particular miner, then he will be, one thing is he'll be rewarded with a new Bitcoin. Okay, a new Bitcoin will be created. And another thing is he will be given the transaction fee of all the transactions. Okay, for example, Alice has given 0.005 Bitcoins as transaction fee. Similarly, every other transaction would have fixed some transaction fees. So all these will be given to that, awarded to that miner. So now once this block is validated, then it will be added to the candidate block. So that the meaning is this block is validated and verified, and now it can be added to the blockchain. Okay, so this is the miner will get. So in this case, to earn more money, the miners, what they will do is when they are working on a particular block to compute that problem, to solve that problem, they will be creating their own transaction. Okay, they will create their own transaction in the block. So what happens is, if they are successful in solving that problem, for their own transaction also they will be rewarded back to their own address. Okay, so they will be rewarded with that that amount will also be paid back to them, so that they can spend it. And for the entire block that they have validated, there will be a block reward, as well as the sum of transactions fee from all other transactions. For example, if you have some 300 transactions in that block, so every transaction would have given some amount of Bitcoins as transaction fee. So all that transaction fees will be given to the miner. Okay. So the amount that he is gaining as reward, that will be added to his account or to his address as a spendable amount. Okay, so the Bitcoin that he has received, it is added to his account, and he can spend it for any other purpose. Praise Winston, it is 9:27 now. Please join on time. So if you see this slide, we can see here this particular Jinx winning pool, they Bitcoin pool, they have worked on it, and they were able to solve that particular problem, and this becomes a winning block for their part. Okay, the example, the number is given as, the block number is given as 277,316. So now they have added this block into the blockchain along with all other blocks. So previously, if you could see, we have several other blocks already piled up here. Okay, so the block number, it starts from block 0. Okay, so from block 0, it has kept on piling up in the same blockchain network. And now this particular Alice transaction is present in this block. Okay, and that was verified by this Jinx mining pool, and they have verified it, and they have added it to the network. Now, so since they have validated it, this become one of the confirmation for that transaction. So the transaction has been made successfully, and the right person has received the money. So this kind of confirmation is made because of this activity. Now, after this, you can see that many more other blocks are also getting piled up. So after this block gets added to the blockchain, now some other miner has created another block which is having some more transactions. So it was verified by some other miner, and it is added, and another block is added. So it keeps piling up. Okay. So when the next block comes here, this block is linked with this block. Okay, every block is linked with another block. So 316 is linked with 315 and 317. 317 is linked with 316 and 318. So it is a chain. So when this 317 is linked with 316, it means that when this is confirmed, then this is also again confirmed. So now it means that the transactions that are present in 316 is confirmed once more. Okay, then only they will be able to validate this block. So it means that whenever a particular block is keep piling up on the blockchain, it means that it is actually verifying or confirming the previous blocks also. So this each block mined on top of the one containing the transaction counts as an additional confirmation. So now 317 block, it is again confirming to Alice transaction. 318 when it comes, again it confirms. Okay, so like this, if it has at least more than 6 confirmations, then there is no possibility of reverting it back. There is no possibility of tampering it or anything. Okay, so it becomes more and more trusted, and it becomes exponentially harder to reverse the transaction. And since the block numbers we have seen here is something 277314, but the origin of the block, it starts from block 0. Okay, so that is called as the genesis block, the initial or the genesis block, from where every transaction that has been made using this Bitcoin is recorded, and it is a public distributed ledger. Okay, you would have heard the term ledger or account book. So whatever, shop, if they are maintaining an account book, then they will be writing every expense, every amount they are receiving, what is the initial balance, what they are spending, what they are receiving, everything they will be having, right? That is for their own thing. But now here in Bitcoin network, this in this blockchain, every transaction that is made out of this Bitcoin will be visible by every user in the network. So it will all be present in the blockchain. Okay, so that is what happening in this Bitcoin mining. So finally, so how we can spend this transaction? So now the transaction is available. The transaction is validated and it is confirmed and added to the Bitcoin. So now it means that the amount that has been sent by Alice, it is already into the went into the account of Bob. So now Bob is able to spend. Okay, now Bob will be able to spend that amount, and he will be creating another transaction to Gopesh. Then if that is validated, then Gopesh will be able to transfer that to someone else. So like this, the transactions can be chained together. Everything is linked. So if we have a doubt, then we can go back and trace where the transaction starts from, who has sent the money and who has used this money. Everything can be traced out using this blockchain. Okay, and today have you completed that assignment I have given in the yesterday's class, the previous class? I've asked you to write about the type of Bitcoin wallets. Have you completed it?
No, ma'am.
No. So I have created
Can
the
you submit it?
assignment link today in the Google Classroom. So
Yes,
today,
ma'am.
then
Can
you
you submit it by
then
tomorrow?
you do it together. Okay. This last slide you can see. Here we are talking about two different clients: full node clients and the lightweight clients. There is one more client. So this is your next assignment. Only 3 clients are given in the book. You can you can just go through it. You write what these different types of clients are, and you just write about that, and what are the different types of clients, and what is the purpose of this, and how it works. You just write it. So along with that, this also is submitted today. Okay. So this full node clients and lightweight clients, they have you just go and check what it is, and you give me the answer tomorrow. Okay, what is the how these kind of clients work to trace the transactions that has been happened. Okay, this lightweight clients, they do a simplified payment verification, whereas full node clients will be able to track the source from where the transaction starts. So there is one more client. You just go and Google it, or look into your book and write it and submit it in the assignment. So now I want to give you a small quiz. So all of you open your
Ma'am,
yes.
ma'am, a small doubt, ma'am.
Tell me.
Ma'am, like miners will be getting rewards, ma'am. So that will also consider as a transaction, no, ma'am.
Minus will be rewarded, right?
Yeah, whenever they will verify a transaction, they will be rewarded.
Yes.
So that is also considered as a transaction. Like if some miner verified the Alice
No, that is not
transaction.
a transaction. That is a new Bitcoin will be created, and that will be in their account. That
Okay.
that is the reward. Apart from that, in that block, how many transactions were there? All the transaction fees will be given to them. In the example we have seen, in that particular block where Alice transaction was there, there was around 420 transactions was there. Okay, so every transaction will provide a transaction fee. So all those transaction fees together will be given to the miner. Is it clear?
Okay, ma'am.
Okay. So now you please open your Google Classroom. Have you all opened your Google Classroom? Are you able to see the quiz?
Yes, ma'am.
So you can start doing it now. Google Classroom code. Which batch you belong to? Andrew Rufus.
Ma'am, batch 2, ma'am.
Batch.
Ma'am, we are not able to access it.
Yes, ma'am.
What it is showing?
Ma'am, it is like logged. It is not able to. We are not able to access.
Okay, 1 second. Now check whether it is possible to open.
Yes, ma'am.
Okay. Okay, I'll give the class code. That's for batch 1. And for batch 2, okay, for batch 1 and batch 2, I have given the class code. Whoever has not yet joined in the Google Classroom, please join and do the quiz now. You can enable your webcam. You can enable your webcam and do your quiz. Students, enable your webcam. Kaushik, have you joined? Kaushik, can you hear me? Can you reply me? Why do you want to join at 9:42? Can I get your response? Okay, if you have completed your quiz, you can leave the class. And please remember to submit your assignment. After completing the quiz, you can leave the class. Yeah, thank you, students. Those are completed. You can leave the class. Thank you. Balu, Balu, have you joined? The class is over. Now only you have joined the class. Balu, are you there?
Ma'am, I was there from starting, ma'am. Like it disconnected in between.
Got disconnected.
Yeah, ma'am.
Okay,
I
have
was there.
you? Okay, okay.
I completed the quiz.
So you just do the quiz
Yeah,
in
completed,
the
ma'am.
Google Classroom.
Yeah, ma'am. Completed.
Okay, okay.
Can we leave, ma'am?
Yeah, yeah.
Okay, ma'am. Thank you.